Yes, dear students, is my screen is visible to you?
Yes, sir.
One more. Is my screen is visible to you or not?
Yes, sir.
Yes, dear students. Dear students, please respond, ma. Is my screen is visible to you or not?
Yes, sir.
Yes, sir.
Okay. So today we'll discuss about some problems on Zener diode. So Zener diode is heavily doped one. Already we know that. It is operated in reverse bias. The main application is voltage source, constant voltage source. It can be used as a constant voltage source. So it is operated in reverse bias, that is breakdown region. So there are two avalanche breakdown. And Zener breakdown. So avalanche breakdown occurs in lightly doped junctions. It is in heavily doped junctions. So here breakdown occurs for less than 6 volts. VR less than 6 volts. And here breakdown occurs at VR is greater than 6 volts. Reverse bias voltage is greater than 6 volts. Yes, have you noted these points, ma? So already we know that this is the symbol for Zener diode. Cathode, anode. And these are the V characteristics in reverse bias. VZ, Zener breakdown voltage. So this is IZ minimum. And this is IZ maximum. So this is for practical one. Whereas for ideal case, these are the characteristics. IZ minimum IZ maximum. So this is for ideal case. If it is delta VZ, and if it is delta IZ, then R Z is equal dynamic resistance. Delta VZ by delta IZ. This is called Zener dynamic resistance. Cathode, anode, this is VZ. Suppose if the diode is on, so when it will be on, when applied voltage, reverse bias voltage is greater than or equal to VZ, then Zener diode on. And what is the voltage across the terminal here? VZ. If it is off, that is when it is reverse bias. When it will be reverse bias, when V is less than VZ. Reverse bias voltage is less than VZ. Then it is open circuit. So this is the case of Zener diode off. See this now? In this characteristics, in this range, when you are applying the reverse bias voltage, when the reverse bias voltage is less than VZ, in this range it is off. It is only in the reverse bias. Whereas when VR is greater than VZ, then breakdown takes place. Then it is on. When VR is greater than VZ, then only the Zener diode will be on. When it is on, the voltage across the Zener diode is how much? VZ. When it is off, When it is off, when VR is less than VZ, then it is off. So it is open circuit. Are you getting these points, ma? Yes, dear students. Say yes or no.
Yes, sir.
So whereas in case of forward bias, it is same as normal diode. The operation of Zener diode in forward bias is same as normal diode. So the main application of this Zener diode is we can use as voltage regulator. Means it produces constant output voltage. So main application is in voltage regulators. Voltage regulator means it will give the constant output voltage independent of the applied input voltage. So what is the circuit here for Zener diode? This is load voltage RL. This is R, and this is input voltage VI. And the voltage across this resistor is VR. And the total current is I. This current is called IZ. This is IL. So this is output voltage V0. I is equal IZ plus IL. V0 is equal IL into RL. So this is VZ. So in any given problem, we have to find the voltage across the Zener diode. If the voltage is greater than Vz, then it is on. If it is less than Vz, then it is off. Suppose if the circuit is like this, excuse me, this is R L, and assume that this as V, and this is input voltage Vi. So what is V here? By using voltage divider rule, anybody? The total voltage across these resistors R and RL is Vi. So Vi is equal to this one. So what is V? The voltage across the resistor RL by using voltage division rule. Vi into RL by R plus RL. So take this as case 1, where Vi and RL are fixed. Vi and case 1 is Vi and RL are fixed. Suppose in this case one, first case, if V is less than Vz, this voltage, that is the voltage across the Zener diode. If V is less than Vz, what happens? What is status of the diode? Yes, Zener diode is off. Yes or no? When it will be on? When the voltage across the Zener diode is greater than the breakdown voltage Vz, then only it will be on. Otherwise, it is in the off state. So here I am calculating the voltage across the terminal of Zener diode. That is V. Suppose if V is less than Vz, then it is off. So when it is off, now what is the circuit status? It is open circuit. It is open circuit. So when it is open circuit, what is the current through the diode? Iz is equal 0. Please respond, ma. The students are getting this point. Say yes or no. Are you there? Is my screen? Yes. Praveen Raju. Praveen Raju.
Yes, sir.
Why you are not responding?
Sir. Sorry, sir.
528. 528. 549. 506.
Yes, sir.
Why you are not responding, ma?
Yes, sir. Sorry, sir.
So IZ is 0. When it is open circuit, the current through the diode is 0. Now this is the total current I. Actually, I is equal to IZ plus IL. Now what IZ is equal to 0 means 0 plus IL. So this implies I is equal to IL. And output voltage V naught is equal to V. Output voltage V naught is equal to V. This voltage is also equal to this voltage V naught. The voltage across the terminal is also equal to the voltage across the terminal. And what is VR? VR, the voltage across the resistor R. What is the current through the resistor R? I. So you can write this as I into R. Or you can also write this as, what is this voltage, ma? This voltage is equal this voltage minus this voltage. So VI minus V. You can also write like this. So I is equal to VR by R. That is VI minus V divided by R. Power dissipation. So what is the power dissipation here? PZ is equal to VZ into IZ. IZ is equal to 0, therefore PZ is also equal to 0. Now come to in case 1, second point. If V is greater than VZ, then diode on. That is breakdown occurs. So when breakdown occurs, what is the status of the circuit? VZ or L. This is VI. I, this is IZ, and it is IL. And this is VR. The voltage across resistor is VR. So VR is equal to same VI minus VZ. That is also equal to IR. And I is equal to IZ plus IL. And I is equal to VR by R, which is also equal to VI minus VZ by R. So when the diode is on, what happens? There is a Zener current flows, IZ. So what is IZ here? IZ is equal to I minus IL. So when the resistor VI as well as load resistor RL is fixed, there are two cases. First case is diode is off, and second case is diode is on. So when V is less than VZ, diode will be on, off, and it is open circuit. And when V is greater than VZ, diode will be in breakdown region, means diode is on. When it is on, the voltage across the Zener diode is VZ. Now we'll do one problem. We'll get some idea. Note on this problem. For the circuit shown in figure below, for the circuit shown in figure below, calculate VR, V naught, IZ, and PZ when VZ is equal to 10 volts. And the circuit is like this. VA is equal to 16 volts. RL is equal to 1 kilo ohm. This is IL, and it is IZ, and R is equal to 1 kilo ohm. And this is VZ, and it is V naught. The voltage across the load resistor RL is V naught. Now take the solution. Yes, have you taken the circuit, ma?
Yes, sir.
Yes. First, you have to find whether the diode is on or off. So, to find the state of the diode, what you have to find? You have to find the voltage across the diode. V means you have to find the voltage at this from this point to this point. So, what is V? We already calculated V. How can you calculate V with this, ma? Yes. Here we have calculated V. What is V? Vi into RL divided by R plus RL. So by using same rule, voltage division rule, we are finding the V. That is the voltage across the diode, Zener diode. So what is V? Can tell me? Same. 1 minute. Vi into RL by R plus RL. That is Va is equal to 16 into 1 kilo ohm divided by 1 kilo ohm plus 1 kilo ohm. That is 8 volts. So here V is 8 volts. So which is less than Vz? Yes or no? What is given? Vz is equal to 10 volts. So here V is less than Vz means what is status of the diode?
Reverse bias.
Diode is just reverse bias. Diode is reverse bias. A reverse bias means it is off. Diode is off. So when it is off, now draw the circuit once again. V naught, and it is open circuit. R 1K. RL is also equal 1K. And this is 16 volts. So what is V naught? This is also equal V. V naught is equal V is equal 8 volts. And what is the V or the voltage across the resistor or voltage across the resistor or VI minus V, that is 16 minus 8, that is 8 volts. Now what is IZ? IZ. When it is open circuit, what is IZ?
0, sir.
0. IZ is equal 0. So when IZ is equal 0, PZ is also 0. PZ is equal VZ into IZ, that is 0. Next problem. Repeat the above problem. Repeat the above problem. For RL is equal 3 kilo ohm. Take the solution. When RL is equal 3 kilo ohm, what is V? Same VI into RL by R plus RL. That is 16 into 3K divided by 1K plus 3K. How much are getting? Yes, 12 volts.
12, sir.
12 volts means greater than Vz. Why? Because Vz is how much? He has given 10 volts. Yes or no? In the problem, he has given Vz is equal 10 volts. So V is greater than Vz means diode is on. Vz is equal 10 volts. So when the diode is on, now what is the state of the circuit? Three K, 1K, that is R, it is RL. This is V naught, and it is Vz. So current flows here, IZ, IL, I, 16 volts. Plus minus. So V naught is equal to Vz, that is 10 volts. This voltage is also equal this voltage. Now VR is equal to Vi minus Vz. 16 minus 10, that is 6 volts. I is equal to VR by R, that is 6 volts divided by R, 1K, that is 6 milliamperes. Now IZ, what is IL? IL, Vz by RL, that is 10 by 3K. Ten by 3K means 3.33 milliamperes. Now what is IZ? I minus IL. I is how much? 6. 6 milliamperes minus 3.33 milliamperes. That is, we are getting 2.67 milliamperes. This is IZ. Now what is power? PZ is equal to Vz into IZ. Vz is 10 into IZ is 2.67 milliamperes. That is 26.7 milliwatts. That is the power. Yes, any doubt in this? The students.
Sir.
Okay, we'll stop here. Wait for 2 minutes more.